Hello my dear students, we are discussing the sums based on 1 upon a plus b sin x plus c cos x, and now you may be wondering that we have already seen so many, why one more? In this module we are discussing the entrance part of it, how to tackle sums based on this in the entrance. Now let us see the general forms. We are well versed with the general forms, a quick look at them. 1 upon a plus b sin x or 1 upon a plus b cos x or 1 upon a plus b sin x plus c cos x dx. Now my dear students, you very well know the method, and any sum of this type we begin with putting tan x by 2 is equal to t. On doing that we get the value of dx as 2 upon 1 plus t square dt, and if I have to write the value of sin x in terms of t, that comes out to be 2t upon 1 plus t square, and likewise cos x comes out to be 1 minus t square upon 1 plus t square. Even in the entrance this question, these steps are valid, but obviously we will not write so many steps. What are we going to do? We are going to skip half the number of steps, and how to remember that in the exam, that is what I am going to explain you. For that we will take the general example, that is the last one. Now if I consider the last integral, it says 1 upon a plus b sin x plus c cos x dx. Correct my dear students? Now in any case, if I were to solve this, the dx in every sum will be replaced by 2 upon 1 plus t square dt. The a remains as it is. The b, which is the coefficient of sine in this case, gets multiplied by 2t upon 1 plus t square, and the c, which is coefficient of cos, gets multiplied by 1 minus t square upon 1 plus t square. If I take LCM, the numerator will become nothing but 2 dt. In the denominator, what I get is a is getting multiplied with 1 plus t square. So let us see that a gets multiplied with 1 plus t square. So can I say the constant term gets multiplied with 1 plus t square? Likewise b gets multiplied with 2t. So can I say that the sine term gets multiplied with 2t? That is, coefficient of sine is getting multiplied with 2t. And likewise, if you see students, c, which is coefficient of cos, gets multiplied with 1 minus t square. That is nothing but coefficient of cos is getting multiplied with 1 minus t square. So for any sum, these are the things I should do. Replace the numerator by 2 dt, multiply the constant term with 1 plus t square, coefficient of sine by 2t, and coefficient of cos by 1 minus t square. So directly we can skip the first 5-6 steps and come to this step. After that we solve normally. Now let us see this in an example. Let us take one question from the entrance point of view in this. Now here, my dear students, we have this question which says integral 1 upon 3 plus 3 sin x plus 2 cos x dx. Now my dear students, we will learn how to apply the method just we have seen. So let me put that in front of you for your reference. So what are we supposed to do? We are supposed to replace the numerator by 2 dt, correct? Because dx gets replaced by 2 dt. We are supposed to multiply the constant with 1 plus t square. So 3 into 1 plus t square. The sine term with 2t, so 3 into 2t. And the cosine term with 1 minus t square. So plus 2 into 1 minus t square. So you may see students, we directly come to half the part of the sum. Now after this it is simple, we have to just open the brackets. So the 2 in the numerator remains as it is. If I open the brackets, I get 3 plus 3t square plus 6t plus 2 minus 2t square. Correct my dear students? Now 3t square minus 2t square. So can I say t square plus 6t plus 5. Now this is what I have, and we have already seen this in the perfect square method. So let us solve further. So integral of 2 upon, can I say t square plus 6t and plus 5 as it is? The fill in the blanks, very well versed with by now. So we have to take half of 6 the whole square, that is half of 6 the whole square will become 3 square, which is nothing but 9. So we add, subtract 9. Now the first 3 terms are nothing but perfect square. So let us just check that. The 2 remains as it is. So can we say 2 upon, can I say t plus 3 the whole square, and 5 minus 9 is minus 4. So can I say minus 2 square. Now this integral which I have is in the form of x square minus a square. Correct? So 1 upon x square minus a square begins with 1 upon 2a. So let us write that. 2 was already present. Now 2 into 2, correct? Log mod of, can I say 2 cancels and we have 1 by 2, correct? So log mod of, you may see I have not written anything because I know the options. If you see the options, I have 1 by 2 present in only one option, which is nothing but option C. So I need not simplify further and check what is there inside the log. Because only one option has 1 by 2, it is by default that option C is my correct answer. So we don't simplify further. And that's all we have in this module, my dear students. Thank you very much.